Okay, so in this uh, video we'll talk about a new method of solving multilinear regressions using the minimization method of sum squared error. Okay, so before that I want to talk something about what is sum squared error and why you do the minimization method. So it's the part 3. So let's write it. Part 3. Okay, part 3 of the homework. Okay, so before starting I just want to clear some things. So over here, as we know, whenever you take, for example, there is some graph is there like this. Okay, and you want to get the minimum point of the graph. So what you do, we take derivative with respect to any of the parameter of this parameter. Okay, for example, x, this is the x, this is y. Okay, the graph is graph is a function of x, for example. Okay, if you take derivative of that function with respect to that independent variable, you will get, and make it equal to 0, you will get the minimum point, this point, because at this point the slope is 0. The derivative of any function, what does it mean? Basically it means the slope, and when the slope becomes 0, we'll get the minimum point. Okay, so when you make it this 0 and equivalent, you will get the point where the slope is 0. Okay, so using this concept we'll learn something today. So see here, there is a linear regression. We have these errors. Okay, these are the errors. So what you do, will take the errors square. Okay, why you take the error square? If you take sum all the errors, see, you will get the sum of the errors. For example, we'll take the sum of the errors. For example, it is plus 4, this is minus 4, this is plus 4 again, this is minus 4 again. If you take sum, it will get cancelled out, and that's the worst thing you want, to get the sum square error. And if you want the sum of the all errors, so to get away from these things, what you do, we square the errors. Okay, we square all the errors, then add, so the negative term become positive and you will get the total error. So just add off of them. This is called sum squared error. Okay, also called in the short form as SSE. Anyways, so you move forward, and once you take the sum squared error and summation of the errors, will take summation of the errors and square it, and derivative, take derivative with respect to any coefficient and make it as 0. Okay, so as we've already discussed previously, like the error is always equal to the vector. For example, y is a vector over here, minus the basis vector. For example, take here as c1 phi 1 plus c2 phi 2, the any base vector. Okay, any base vector. So we can say like this, e is equal to y minus summation of I is equal to 1 to n ci phi I. You can say like this. Okay, and if you see error square, if you take error square of something, okay, we'll see over here. If you take square of any error, that is exactly equal to the dot product, as I've already discussed. Let me tell you again. If you take dot product of a dot a, it will become a magnitude, the magnitude of a, into cos theta, and as theta is 0 between the same vectors, because same vectors, no, the angle it makes with itself is 0, so it will become 1 and the answer become square. So we can take, so using this formula you can take dot product of these two things. So let's do it. e square is equal to dot product of y minus summation of I equal to 1 to n ci phi I dot y minus summation of I is equal to 1 to n ci phi I again. Okay, then if we expand this, the commutative rule of dot product y into y, it will become y squared. Again here there is a minus term, minus this term into this term. Again we will have to multiply what you call see this term into this term. Okay, we'll get one term, and again you will get this term into this term. Okay, so we'll get two these terms, so we'll add them together, minus 2y summation of I equal to 1 to n ci phi I. Okay, now we'll get these two terms, and two summations are there. When we add them together, minus minus plus summation of, rather than taking I and getting confused, you are taking new numbers, new parameters like p equal to 1 to n and summation of q equal to 1 to n. Okay, now cp cq phi p dot phi q. Okay, so this is the e square, and we want the minimization value, so we'll take derivative of e, it's the error, derivative of error with respect to the coefficient c. Okay, so if you I don't want to make you confused, so I'm taking cj. Okay, a new parameter over here, cj. So if you take derivative of this, you see there is no cj term in this term. Okay, in this first term there is no cj term, only y is there, so it's become constant, so it will become 0. So we'll take 0 minus, here if you see, when you take summation from 1 to n of this number, of this ci and phi I, only the term where I will equal to j, that term will survive, because cj dcj by cj, it will become 1, and other terms will be constant, so every term will be 0 apart from where c equal to j, means j is equal to I. Okay, at this term only will survive, and apart from that, all the terms will become 0. So we can write like this: 2y, it will become 1, so phi I you can write. Okay, only when j will be equal to I, the term where j will be equal to I, that term will only going to survive. Okay, now moving forward, here in this case we will get two cases, actually four cases. Okay, so the first case where p is not equal to j and q is not equal to j. In this case, what will happen, every term will be constant. Okay, every term will be constant with respect to cj. Okay, so what will happen, so it will become, the derivative will become 0, so it will become 0. Okay, and this term will become 0. What next term, whatever the next term where p is equal to j but q is not equal to j, here what will happen, see, here take the first summation for p is equal to j. Okay, for for the first term cp will be equal to cj. Okay, and when you take derivative with respect to cj, it will become 1, and only this term will taken over, will survive and will be multiplied with this term, these terms like cq phi j dot product phi q. Okay, these terms, the phi p phi j will become 1, and it will be multiplied over these terms, and all the terms will be there apart from the term where q equal to j. Okay, so you can write like this: q is not equal to j, only this term will not going to be there, apart from this all the terms will be there. Okay, So you can write like this: C Q phi J dot product phi Q. You got my point? Like I wanted to say, like uh, when you take derivative, the Cj term will come out for the summation and it will become 1, and it will get multiplied with all the terms apart excluding the term q equal to j. Okay, because it will become 0. I'm sorry, q not equal to j, because it will become 0. Okay, so similarly this is the second case. Okay, this is the second case. The third case will become when p not equal to j and q is equal to j. Here I'll get similarly, well, p not equal to, only this term will not going to be there, and apart from that all the terms will be there. C is p not equal to j. Okay, c okay, will be doing q equal to j. Okay, this term will be j, so it will be, become 1. Apart from that, cp will be there, phi p will be there, and phi j will be there. Okay, dot product plus, and the last and not the least, this case it will become p equal to j and q equal to j. In this case, what will happen, both the terms will be there. Cj, this is q will equal to j, c is p is equal to j, so it will become cj into cj, it will become c square. Okay, cj square, and phi j dot phi j. Okay, when you take derivative of that, it will become 2cj phi j dot phi j dot product phi j. Okay, so now it is going to get interesting, because if you see over here, as I told earlier, in these terms we don't have the cj term. Okay, the cj term is missing. Apart from the cj term, all other are there. So if you take one cj term from here, you can see two cj terms are here, cj phi j, the cj phi j phi j are there, only the j terms are here. So you take one from here and add it up in it, and one term from, take one term from here and add it up in it, will get uh, let's make it as 0, because you wanted to make this as 0 for minimization. So 0 is equal to minus 2y phi I plus, if you add all of them together, we'll get the perfect summation. It's all the sums will be there, because the j terms were missing over here, one j term was missing over here, one j term was missing over here, and we added the two j terms in here. So the total summation will be, taking, without taking any other number, I'm taking I equal to 1 to n. We got all the numbers, c ci phi I dot phi I. Okay, which is equal to 0. Okay, and 2 will be there. Okay, forgot I. Okay, for this term we get it complete sum, for this term also we got it complete sum, so it will become 2. Okay, see, we added, it was only j term was missing, we added one j term over here, it will become a complete sum. Again, one j term we added over here, so it will become a complete sum. So two complete sums are there, so we added these things, is equal to 0. 2 will cut the 2, and minus term is there. So let me do it properly over here. Summation of I equal to 1 to n ci phi, as I told earlier, you can write the dot product as multiplication of the transpose of that vector multiplied, vector multiplied by the second vector. So we did like this, and similarly over here, phi I transpose of j. So if you see over here, we got something similar thing, which is equal to phi I transpose multiplication phi I to ci, then phi I transpose into y. If you see, you have already done this. This is the design matrix. Okay, and we have taken the transpose of design matrix, transpose of the design matrix, and we multiplied the both the places. Okay, and this is the coefficient matrix, coefficient matrix. Okay, so we have derived this thing, so which it can be also derived as, see, these are the 5 ones all are added together, then obviously they are transposed, then 5 1 5 2 5 3. Okay, then this is the coefficient c2 c3, then again you can write like this. I'm writing over here again transpose of this design matrix 5 1 5 2 5 3, and the vector matrix y2 y3. That's all. Okay, so we got this thing. So we derived it from the sum squared error method, the same thing, the matrix vector equation for linear regression. So let's try to solve it, and we'll see using the first part, the question which is solved using the matrix vector equation. We will try to solve it using the minimization method. So let's go over there. This was the first problem which we did it using this method. Let's try to solve it using another method, and we'll see whether we are getting the data or not. So to get that, to use that thing, use the minimization method, you need to call another function, another module from scipy dot optimization, optimize import minimize. Okay, we imported this, shift enter. Now let's define a function called ssc. Okay, we need to give a vector into it which will unpack, okay, into how many variables we have, 1 2. Okay, x square plus sine x we have, so 2, like you can take a and b is equal to t. Okay, then we need to return that, sum square error. So sum, okay, what is the error? Error means, as I told, y, you know the no, the difference between, what you call the difference between, or what is the error? As I told, error means always the difference between the vector and the base vector. Okay, so what is the vector over here? Yeah, this one. Okay, as you're taking the sum, so you can also take the alternative way. You can take that thing first, or not at the end, then y. Okay, we're taking y, and we will be taking the square of it. Okay, shift enter. Now we'll call the minimize function, minimize, will pass the argument as ssc, and we need to give an approximation, means, and with data, approximation to converge. Okay, you can just approximate whatever, for starting, like you can take 0.1 and 0.1 and shift enter. Oh, okay, successfully it got optimized. To get the values of x and y, you can see over here, this is 1 and 1. To get it clearly, we'll just dot x. Okay, so we got 0.1 and 0.1, and you can see using the first method, matrix vector equation, we solved it, and we see the value is almost close. The value of, which you solved over here, it's almost close. Okay, I need to put A over here. Okay, I made a mistake. A, B, yeah, it will come now. Yeah, it's pretty much close now. See, the first one is 0.9947, it's here 0.9947, and this one is 0.1, it's 0.99. okay, it did not came that close, but it's almost pretty much close. Okay, okay, let's try something else like uh, 1 and 1. Let's see. Let's try 0 0. No, it's not working. 1 and 1. Okay, I need to pass two parameters. Yeah, it's now almost coming almost close. See, 0.99 and 1, 0.99 and 0.99. Yeah, so pretty much close. So it does work. And yeah, so that's all. Thank you.